Right, children. Let us start with the assignment. This is second assignment of alcohol, phenols, and ethers. Nomenclature. CH3, CH2, CH. I'll not write hydrogen to save time. CH, CH3 twice. This will be the direction of counting. This is 4-methyl 3-pentanol. 4-methyl 3-pentanol, and this is secondary alcohol. Next, CH3COH double bond CH3. This will be the direction of counting. IUPAC name will be but-2-ene-2-ol. I'll repeat, but-2-ene-2-ol, and it's a secondary vinylic alcohol. Secondary vinylic alcohol. Third, CH3CHOH CH double bond CH2. This is the direction of counting. This is but-3-ene-2-ol. OH is given more preference. This is the direction. but-3-ene-2-ol, and this is secondary allylic alcohol. Now coming to fill in the blanks. First sequence. Tertiary-butyl alcohol with aqueous NaOH will not give tertiary-butyl chloride with aqueous NaOH will not give alcohol. This is not NSR. This is an elimination reaction because it is tertiary alkyl halide. So product obtained will be an alkene. This is 2-methyl propene. Next. Then sulfuric acid hydrolysis. This is a hydration of alkene. Addition of water will take place according to Markovnikov's rule. Product is tertiary-butyl alcohol. With sodium, this will give a sodium salt. This is nothing but acidic nature of alcohol. This is C. Then this is reacted with bromoethane. Next reaction is Williamson synthesis. This will lead to the formation of an ether. This is first sequence. Coming to second sequence. Product in the reverse arrow is tertiary-butyl alcohol. One reactant is given above the arrow. This is methyl Grignard. Then the second reactant is acetone. This is the reaction which, if you remember, it took me 20 minutes or 25 minutes to explain. This is a very important reaction, will be used in many reactions and many conversions. So methyl Grignard is given above the arrow. Product we have to prepare tertiary-butyl alcohol. It means the answer for A is a ketone, that is acetone. Now this acetone is reduced with LiLH4. Reduction of ketone gives a secondary alcohol. 2-propanol. Now 2-propanol is reacted with acetyl chloride. I'll tell you what is acetyl chloride. See, acetyl chloride is CH3COCl. Chlorine from here, hydrogen from here will be eliminated as HCl. I'm writing this part, CH3CO. This carbon will form a bond with this oxygen atom. So remaining this part will come here. This is the ester obtained. Isopropyl acetate is the common name of this ester. Third sequence. We are given propanol. Propanol is reacted with A. Hydrolysis gives 2-butanol. Answer is CH3MgX. In case anyone has any doubt how to apply this reaction, once or twice I can explain. Anyone wants to ask, I can explain. So this is methyl Grignard. 2-butanol with hot copper. This is oxidation will give a ketone. 2-butanone. Now, this ketone is further reacted with iodine NaOH. This is iodoform test. You can see 2-butanone has required group for iodoform. So this on reaction with iodine NaOH will give iodoform and sodium propanoate. Sodium propanoate is the second product. Fourth sequence. Somewhere in the middle, we are given tertiary-butyl chloride. We'll start with that. Tertiary-butyl chloride with aqueous NaOH gives D. Product is alkene. This alkene with diborane and hydrogen peroxide, hydroxide ions. This is nothing but hydroboration oxidation in which water is added according to anti-Markovnikov's rule. So product will be, this is the product, this is isobutyl alcohol. Now, going back, tertiary-butyl chloride is obtained by the reaction of C with PCl5. It means C is tertiary-butyl alcohol. This tertiary alcohol is prepared by the reaction of methyl grignard with B. The same reaction we used above in one of the sequences. Answer is ketone, acetone. And this acetone is obtained by the reaction of A with hot copper. This is secondary alcohol, that is 2-propanol. Explain why. All the answers you'll find in your notes. Coming to what happens when. These two I'll explain verbally. Vapors of 2-butanol are passed over hot copper. First part says oxidation takes place and 2-butanol will be oxidized to 2-butanone. And product is reacted with ethyl magnesium bromide. So 2-butanone, which is obtained, this is reacted with ethyl magnesium bromide. Product obtained will be a tertiary alcohol. Now, what is the structure of this tertiary alcohol? This will be the tertiary alcohol which will be ultimately obtained. Second, ethanol is reacted with acetyl chloride in the presence of a weak base. This weak base which you're talking about is nothing but pyridine. So reaction is esterification and leads to the formation of a sweet smelling ester. I like the structure of ester formed. This is the ester formed along with HCl, sweet smelling ester. Coming to conversions. Normal propyl alcohol into tertiary pentyl alcohol. I told you earlier as well, whenever we want to prepare an alcohol which contains more number of carbon atoms than the starting metal, most likely you'll have to use the reaction between Grignard reagent and a carbonyl compound. Now, in this case, the last step will be, we are preparing a tertiary alcohol. Last step will be reaction between a ketone and Grignard reagent. See, this carbon which carries OH, will come from C double bond O. Apart from this, there are 2 methyl groups and 1 ethyl group attached to carbon. Methyl groups will come from here. So this will be 3 carbon atoms. Starting metal is also a 3-carbon compound. This will be converted into this and will be reacted with ethyl Grignard. So acetone has to be reacted with methyl Grignard followed by hydrolysis. Now, our task is to convert 1-propanol into acetone. How do we do that? I taught you one reaction, dehydration of alcohols last time. This is concentrated sulfuric acid, 170 degrees centigrade. If you do not remember this, convert alcohol into alkyl halide, then dehydrohalogenation will give the same alkene, that is propene. Add water according to Markovnikov's rule. This is hydration, and this hydration will be in the presence of sulfuric acid. sulfuric acid, hydrolysis. Hydration, according to Markovnikov rule, this is one method. I told you one more method, that was oxymercuration, demercuration. This is your choice, which reaction you want to use. Now this will be converted into acetone, simple oxidation. You can use hot copper. You can use PCC in the presence of methylene chloride. You can use anhydrous CrO3. And there are two more oxidizing agents, acidified KMnO4 or dichromate. Remember all oxidizing agents, and you should know where to use a particular oxidizing or reducing agent. Next, second conversion, methanol into ethanol. I want to prepare a primary alcohol which contains more carbon atoms. And to prepare primary alcohol, I have to react formaldehyde with a Grignard reagent, HCHO and methyl Grignard. I can convert methanol into formaldehyde by oxidation. I can use hot copper. Third, tertiary-butyl alcohol into isopentyl alcohol. Try to understand, this will help you in fill in the blanks also. Again, I'm explaining once more I'm explaining. Product is alcohol, contains more carbon than the reactant. Now, this carbon which carries OH, this comes from C double bond O. This is attached to hydrogen and isobutyl. If you remember, I told you in this reaction, hydrogen atoms will not come from Grignard reagent. It means both the hydrogen atoms will come from carbonyl compound. This remaining part will come from Grignard. And you can see this arrangement and this arrangement of carbon atoms is same. So this will be converted into Grignard, which will be reacted with formaldehyde. How to convert this into Grignard? First reaction we used earlier also today, that is dehydration, sulfuric acid at 170 degrees centigrade. After that, add HBr according to anti-Markovnikov rule, HBr, organic peroxide. Convert this alkyl halide into Grignard reagent, magnesium diether, this X is bromine, to get the final product. Propene into 1-butanol. Propene into 1-butanol. After I finish the assignment, please do not log out because some children have joined only for the assignment. I'll take the attendance after that log out. Again, alcohol with more number of carbon atoms. React Grignard with HCHO. Final product is a primary alcohol. I'll have to react Grignard reagent with HCHO and we get a primary alcohol. Convert this into Grignard. Very simple reactions. Anti-Markovnikov addition, HBr peroxide, and after that magnesium diether, final reaction. Now, one more question to be discussed. Giving reason, arrange glycerine, ethyl alcohol, and glycol in their increasing viscosity. Remember, more the number of OH groups, stronger will be the hydrogen bonding, and more will be the viscosity, higher will be the boiling point, higher will be the density, everything. So in this case, the answer is based on number of OH groups. Glycerine will have maximum viscosity because maximum number of OH groups, therefore maximum hydrogen bonding. Ethanol will have least viscosity because this has only one OH group and therefore least hydrogen bonding. Glycol will be in between these two, right?